Some of you may have attempted to connect an Arduino to the internet using Wi-Fi. You've probably noticed that that connection is not always reliable. There are numerous queries about this on the web. I would like to share with you how I made my connection much more robust and reliable. Basically, I use an Arduino Nano as a watchdog. It generates a hardware interrupt for the Arduino Uno that runs the web server. Here is a simple demo of a radio-controlled main socket that I switch on and off with my mobile phone, either at home or remotely. You notice the switching from the LEDs that go on and off, and you hear the click of the relay in the switch. This schematic illustrates how it works. If there is a request from the internet, the Uno passes on the message to a 433 MHz transmitter. The message is received by the RC switch and the appropriate action is taken. Occasionally, the internet link hangs and it is no longer possible to get access to the server. That is where the Nano comes in. These things are very cheap, and in this case you don't need a separate power supply. You can simply tap into the 5 volt from the Uno. At regular intervals, you let the Nano generate an interrupt on one of the interrupt pins of the Uno. Before generating the interrupt, we register the current state of the switch. That is done by reading pin 8 of the Uno in my case. After the interrupt, you report that state back. We run out of digital pins because they are all taken up by the internet shield, so we use one of the analog input pins. Here we see the various components. The tiny element on the prototype shield is the 433 MHz transmitter. I've added an antenna to improve the range. You can get up to 100 meters if there are no walls. Between the Uno and the prototyping shield sits the red CC3000 internet shield. There is a library from Adafruit to communicate with this shield. This is the Nano. As I said, it's powered by the Uno. I bought a set of 4 radio-controlled switches. They come with a remote control. The trick is to break into the codes that are transmitted from the remote control. That is pretty straightforward by using a receiver and a sketch that you can download from the internet. This program picks up the code and displays it on the computer screen. In the RC switch library are the functions to do that. First, we define an interrupt pin to receive the binary code that is picked up. The received signal is decoded and the result is printed on the screen. This is the list of codes for my set of switches. The last 2 digits select the switch and the control action. There is also feedback on the number of bits and the protocol used. Let's now look at the code of the 2 Arduinos. This is the setup section of the Uno. Here we start, or after an interrupt we restart the Wi-Fi connection so we can begin listening on the internet. It also checks the previous lamp state as it is remembered by the Nano. As I explained, we use an analog pin, so for a high we simply check if the value is above 500. If that is the case, then the lamp was apparently switched on before the interrupt, so we confirm that by transmitting the code for the on state. If not, then we send the code for the off state. Before we move into the loop, we enable the interrupt on pin 2. If the state of that pin goes from low to high, we call on the subroutine reboot. Reboot basically causes the program to start running from address 0. As such, it's not a hard reset, but just a restart to reboot the Wi-Fi chip. Let's now look at the Nano and see how we realize the watchdog function. The sketch is very simple. We first need some pin definitions, one for the interrupt, one to pick up the status, and another one to return the status to the UNO. In the loop we generate the interrupt, in this case every 10 minutes, but that can be any period you want, of course. We first pick up the current lamp state. We write a high to the interrupt pin, and we also report back the lamp state. And that's all it takes to make a Wi-Fi link more robust. Let me know if this makes sense, or post other suggestions. Thanks for watching.